When it comes to solving logarithmic equations, there are two different and distinct types of problems we're going to see. The first one is if every term in the problem has a log in it, and we're going to use canceling when it comes to that. If not every term has a log in it in the equation, and it's equal to a constant number, we're going to use down and diagonal. All right, we'll see what that means coming up. So let's just apply some of these simple rules to our first problem. It's going to say solve, and that means solve for x, get x by itself. Log base 6 of 5x equals log base 6 of 2x plus 9. Now this one's a much more simplified problem than ones we're going to see, but in this case, if we look at it, we've got one term on the left, one term on the right. Both have a log base 6. They have the same log. So if there's one log on the left and one on the right, we can cancel out these logs and bring everything else down. And now, without the logs, this is something we can solve. Subtract 2x over, we get 3x equals 9, and dividing by 3, x equals 3. Now we will have to check something later on. If I plug that number back in, it creates a negative answer in here, then we have to cancel that out. It's kind of like an extra solution. So if we plug it in here, if we get negative, no, that's a positive 15. If I plug it in here, 6 plus 9, also a 15. So we're not getting negative logs. We can't have negative logs. All right, so let's see how we can apply this to other ones. So another one, we want to solve it. Let's say they gave us log base 10 of x plus 1 minus log base 10 of x equals log base 10 of 29. So let's see what type of problem we have. We've got two terms on the left, the log x plus 1 and the log x, and one term on the right, which is the log 29. Okay, so every term has a log, so we're going to be using canceling, just like we had on the first one. The problem is, I need one log on the left and one log on the right. This right side's already good, okay? It only has one log, so I'm going to write that. Over here, we have two logs. I need 1 and 1 to cancel, not 2 and 1. Those don't cancel. But if you think back to a previous lesson, we do know a way that we can condense these two logs into one, so we only have one log. The way we do that is by looking at how they're attached. That's a minus sign. That's going to become division. Remember, subtraction goes with division when we're condensing. We have the log base 10. We read it from left to right. The x plus 1 is going to go on top, and the x is going to go on the bottom. And the great thing now is I've got the log 10 on the left, cancels with 1 log 10 on the right, and we bring everything else down. X plus 1 over x equals 29. And now this is solvable. Whatever method you're going to use, whether it be cross multiplying or multiplying both sides by x, you've got x plus 1 equals 29x if you multiply both sides by x. And then bringing the x's together, x equals 1 over 28. And there you go, you've got an answer for x. So sometimes those logs, you have to condense them down in order to get one log, and so that log will cancel. So let's see another one of those. Let's say log base 5 of 48 equals log base 5 of 6 plus log base 5 of 2x squared. So again, I want to look at this as a whole. One log term on the left, two on the right. But they all do have log in each term, so if we are able to condense this down, we'll have 1 and 1 and the logs will cancel. So I look at it, we've got addition, that's going to become multiplication. So we're going to have 1 log base 5. This times this. So I'll break it up. 6 times 2x squared, all in there. So really that's going to be log base 5 of 12x squared. Still equal to this side, which we didn't need to change at all. But since we've condensed down the right side, this log can cancel with that log. Only 1 and 1 can't cancel 1 with 2. We can bring everything else down. Solving for x, divide by 12. 4 equals x squared. We need to square root this. So x equals plus or minus 2. And what that means is we've got two answers. X equals positive 2 and x equals negative 2. Now when it comes to two answers, we don't want to stop and automatically say that both are correct. We want to look and plug those back in and see if we create negative logs. So if I plug it in here, if I plug in positive 2 or negative 2, there's actually nothing to plug in, so nothing happens there. So this is okay for both. This is okay for both. Here, if I plug in positive 2, positive 2 squared is 4 times 2 is 8. Even if I plug in negative 2, negative 2 squared is positive 4. Positive 4 times 2 is still a positive 8. And if it keeps it all positive, we're okay. So actually both numbers are still good, but we just had to check. If we ever create a negative number in that log, we can't use it. Alright, so sometimes we might have to cross out answers. So let's see another problem. Let's say log base 10 of 2 plus log base 10 of x equals 1. This is the other type of problem. So here's my equal sign. I've got a log, and a number. So not every term has a log. This time we're going to be using the down and diagonal method. So if it's ever equal to a constant, I'll write that there, constant number, so a number all by itself, we're going to use down and diagonal. But in order to do that, we still need to condense. So no matter what type of problem we have, there's going to be some condensing involved. So we have addition, that's going to become multiplying when we condense it down. So log base 10 of 2 times x, so 2x, equal to 1. So we still need to get rid of log, but since we can't cancel them, we're going to use down and diagonal to make this exponential form. 10 comes down, 1 becomes the exponent over here, and 2x goes the other way. 10 to the 1 power is just 10. And then we got 2x. And dividing both sides by 2, x equals 5. And there we go for that one. We got a nice answer of 5. So sometimes we're able to cancel everything out. Other times we need to use down and diagonal. And we can tell by looking at the original problem which method we're going to have to use. So again, log base 5 of x squared minus 10 minus log base 5 of 3 equals 1. And just hearing that, equals 1, equals a constant, we're going to use down and diagonal. Still need to condense this side down. It's subtraction, so it's going to become division. So log base 5, top, x squared minus 10, bottom, 3 equals 1. Now let's do our down and diagonal. The 5 comes down, the 1 becomes the exponent, equals, this whole chunk moves to the other side. X squared minus 10 over 3. 5 to the 1 is just 5. Alright, let's start getting x by itself. Looks like we got to multiply both sides by this 3. 15 equals x squared minus 10. Getting x by itself, we need to add 10 over. So we get 25 equals x squared. And finally, take the square root of both sides. X equals positive 5 and negative 5. Remember, when you square root, you need a plus or a minus. And I just want to check real quick. If I plug either of those numbers in, will I create a negative? So I look like I need to square it. And anything we square, whether it's positive 5 or negative 5, is going to come out positive. Minus 10, so 25 minus 10 either way still comes out positive. So both these numbers are still good as answers, positive 5 and negative 5. All right, looks like one last one for the notes. Negative 6 times log base 3 x minus 3 equals negative 24. Now, we've seen it before where this 6 could come up and become the exponent, but that's actually making it more complicated. If we think about it, it's attached by multiplication, so just divide it off right now. So if there's an extra funky number up there, just divide it off in the beginning. So we got log base 3, x minus 3 equals positive 4, and there's actually no condensing now because we only have one log term. This side's a constant, so we're using down and diagonal. 3 to the 4th power equals x minus 3. 3 to the 4th, that's 3 times 3 times 3, that's an 81. Equals x minus 3, and then finally adding 3 to both sides, you get an answer of 84. So sometimes it looks a lot more complicated than it is. Something there you just divide that number off. But remember, either way, there are two types of problems when it comes to solving these logs. Either everything has a log in it, or it's equal to a constant. And they tell us different methods to use for either one.